Number 1. The purple poison. Earth's billion-year toxic ocean. Picture yourself standing on the edge of a coastline 1.8 billion years ago. The water stretching to the horizon is not blue. It is a deep, bruised violet, opaque and thick. The sky above carries a sickly, pale green haze, and the smell, hydrogen sulfide, the stench of rotten eggs is so concentrated it would paralyze your nervous system before you could turn away. At 50 to 100 parts per million, hydrogen sulfide destroys the human sense of smell entirely. At 1,000 parts per million, it causes immediate neurological collapse and pulmonary edema. You would be dead in seconds, and the ocean itself would look utterly alien. This was not a brief catastrophe. The purple ocean persisted for approximately 1.2 billion years, from roughly 1.8 billion to 540 million years ago. That makes it the longest single hostile state in Earth's recorded geological history. To put that in perspective, the entire age of dinosaurs lasted about 165 million years. The purple ocean endured more than 7 times longer. The chemistry behind it begins with oxygen, or rather the near-total absence of it. Atmospheric oxygen during the Proterozoic eon was so low that organic matter on the seafloor could not oxidize. This created a massive buildup of sulfate in ocean water. And that sulfate fed an entire class of organisms that would dominate the planet for over 1 billion years. Their name is Chromatiaceae, more commonly known as purple sulfur bacteria. These microbes colonize the photic zone, the upper layer of the ocean where sunlight penetrates, and they performed a type of photosynthesis fundamentally different from what plants do today. Instead of using water as an electron donor, they used hydrogen sulfide. It is, in every metabolic sense, an alien form of life by modern standards. The blooms they produced were so vast they created a global color shift. Satellite imagery, had it existed, would have shown an opaque violet ocean visible from space. And the hydrogen sulfide they metabolized did not stay in the water. It vented into the atmosphere, reacting with other gases to produce the permanent pale green haze that blanketed the sky. Geochemist Donald Canfield first proposed this model in 1998. His Canfield ocean hypothesis describes a stable euxinic state, a water column simultaneously oxygen depleted and sulfur rich, maintained by bacterial feedback loops. The technical term euxinia comes from the ancient name for the Black Sea, and it refers to conditions where water is chemically hostile to all aerobic life. The specific horror here is what researchers call photic zone euxinia. The toxic layer was not confined to the deep, it reached the surface. Even the shallowest coastal waters were lethal. Without meaningful temperature gradients between surface and deep water, ocean currents essentially stopped. No mixing, no renewal. The entire ocean became a planetary cesspool. Sulfur did more than poison the water. It stripped dissolved iron from the water column, precipitating it as pyrite fool's gold on the seabed. Entire ocean floors became iron graveyards. Meanwhile, hydrogen sulfide gas venting into the atmosphere slowly eroded the ozone layer, allowing ultraviolet radiation to sterilize any experimental surface life. The atmospheric haze created a greenhouse effect, trapping heat and making surface water tepid and viscous. For 1 billion years, a span sometimes called the boring billion, Earth was dominated exclusively by microbial mats. Complex multicellular life was chemically forbidden from evolving. Some researchers refer to this period as the slime world. Organic material that sank into the deep did not decompose. It was preserved in sulfurous brine, a natural embalming process that created some of the oldest chemical fossils in the rock record. The surface was eerily still. No waves as we know them. No meaningful agitation. Just the slow bubbling of toxic gas venting from below. Now, not every researcher agrees the purple ocean was truly global. Some geologists argue the euxinic conditions were patchy, localized to restricted basins rather than blanketing the entire planetary ocean. The evidence for global coverage is strong, but debated. And then there is the fringe perspective, one that comes from astrobiologists rather than geochemists. They propose that purple sulfur bacteria may represent the default photosynthetic pigment for life in the universe. Earth was purple before it was green. And when telescopes scan exoplanet atmospheres for signs of life, the signature they may find is not chlorophyll. It is bacteriochlorophyll, a purple world. What makes this more than ancient history is that the end Permian extinction 252 million years ago briefly recreated purple ocean conditions. The Black Sea today is euxinic below about 150 meters. The Baltic Sea's dead zones show the same chemistry. Euxinia is not a phase Earth outgrew. It is a failure state the planet can snap back to. And the next entry on this list shows that Earth's deadliest killers are not always asteroids or volcanoes. Sometimes they are trees. Number 2. The late Devonian Catastrophe. The trees that murdered the sea. 375 million years ago, the evolution of forests on land directly triggered a mass extinction in the ocean. Life killed life. That is the central paradox of the late Devonian Catastrophe, and it begins with a single biological innovation: roots. Early trees like Archaeopteryx developed deep, aggressive root systems for the first time in Earth's history. These were not shallow, matted filaments. They penetrated bedrock, physically and chemically, grinding down rock into soil in a process geologists call pedogenesis, biological weathering. For billions of years, minerals like phosphorus and nitrogen had been locked inside continental rock, inaccessible to any ecosystem. Roots changed that. Rain washed these newly liberated nutrients from freshly generated soil into rivers and then into the oceans. It was an unprecedented nutrient injection on a planetary scale. The result was algal blooms. Not modest seasonal blooms, but events covering thousands of square miles of ocean surface. A planetary green tide. And when those algae died and sank, decomposition bacteria consumed all available dissolved oxygen in the water column. This is the classic eutrophication cascade, the exact mechanism that creates dead zones today. The geological fingerprint of this oceanic suffocation is the Kellwasser black shales, sedimentary layers so oxygen depleted they are jet black. They have been found at sites across the globe. The casualties were staggering. Armored fish like Dunkleosteus, 20-foot apex predators encased in bony plates, suffocated in water that could no longer hold oxygen. They drowned in the most literal sense. The world's largest reef systems, built by stromatoporoids over millions of years, were smothered by algal slime and collapsed entirely. It took 20 million years for coral reef ecosystems to reappear. That is one of the longest reef absences in the entire fossil record. There is a compounding irony. The massive new forests absorbed so much carbon dioxide from the atmosphere that they triggered an unplanned ice age. Global cooling caused sea levels to fall, trapping marine organisms in shrinking, shallow, increasingly toxic pools. Root weathering also liberated toxic heavy metals, mercury, lead, into the water table, and eventually into the ocean. And because fungi had not yet evolved the enzymes to decompose lignin, wood fiber, dead trees piled up in miles, thick mats, choking rivers and waterways. On land, oxygen levels spiked from all the photosynthesis. Forest fires burned at temperatures high enough to vitrify sand into glass. Researcher Algeridas Ainsar and others tie the Freycian Fominian extinction boundary directly to eutrophication from terrestrial weathering. This is the mainstream view, a biological cause, not a cosmic one. Some paleontologists argue the extinction came in multiple smaller pulses driven by tectonic shifts and volcanic activity coinciding with forest expansion. And a minority view holds that a gamma-ray burst or bolide impact overlapped with the plant expansion, and that biological weathering alone cannot explain the severity. Today, agricultural runoff creates identical dead zones. The Gulf of Mexico's hypoxic zone, roughly 15 to 22,000 square kilometers every summer, is driven by the same phosphorus-nitrogen mechanism. The Devonian catastrophe is not ancient history. It is a chemistry experiment still running. But the next event on this list did not poison an ocean. It erased one entirely. Number 3, the Messinian salinity crisis. The Mediterranean that vanished. Imagine standing on a salt flat 3,000 feet below where sea level should be. The air temperature at the basin floor reaches 80 degrees Celsius, 176 degrees Fahrenheit. The white expanse stretches to every horizon. This is the floor of the Mediterranean Sea, and it is bone dry. This crisis lasted from 5.96 to 5.33 million years ago during the late Miocene, roughly 630,000 years of a missing sea. The trigger was tectonic. The closing of the Betic and Riphean corridors, precursors to the modern Strait of Gibraltar, severed the Mediterranean's connection to the Atlantic Ocean. And the math is simple. The Mediterranean loses more water to evaporation than it receives from all its rivers combined. Without Atlantic inflow, it runs a net negative water budget. The entire sea vanished in roughly 1,000 years. A geological blink. The heat at the bottom was governed by adiabatic physics. As air descends into a deep basin, it compresses and heats, the same principle that makes Death Valley hot, but pushed to an extreme. Atmospheric pressure at the basin floor reached 1.5 to 2 times normal sea level pressure. The air was denser, hotter, and nearly unbreathable. What the vanished sea left behind was extraordinary. an evaporate layer up to 3 kilometers thick accumulated on the former sea floor. It is one of the largest salt deposits in Earth's history. Rivers had to adjust. The Nile, the Rhone, and other major waterways cut thousands of feet downward to reach the new base level. The Nile carved a gorge at Aswan deeper than the Grand Canyon. Removing trillions of tons of seawater caused the Earth's crust to spring upward in a process called isostatic rebound, triggering massive earthquakes across the entire Mediterranean basin. Land animals seized the opportunity. Elephants and hippos walked across the dry salt flats to reach what are now islands like Malta and Cyprus, accessible as hilltops in a vast desert. When water returned, these animals were stranded. They evolved into pygmy versions. Dwarf elephants and dwarf hippos have been found as fossils on Mediterranean islands, products of insular dwarfism under resource constraint. The return of water was the most violent part. When the barrier at Gibraltar finally broke, it produced the largest flood in Earth's history, the Zanclean Flood. Atlantic water surged through the breach at speeds exceeding 90 miles per hour, carrying roughly 1,000 times the flow of the modern Amazon River. Sea level in the basin rose up to 10 meters per day. The entire Mediterranean refilled in approximately 2 years. The roar of that water pouring through the strait would have been audible for hundreds of miles. Kenneth Xu, William Ryan, and Maria Biancasita first proposed the deep desiccation model in 1973 based on drilling data from the Deep Sea Drilling Project Leg 13. Some researchers counter with the shallow water, deep basin model, arguing the Mediterranean never fully dried, instead maintaining deep hypersaline lakes while peripheral areas desiccated. A fringe view suggests the Zanclean flood was not a single catastrophic breach, but a series of smaller overtopping events over thousands of years. The Mediterranean's tectonic configuration has not fundamentally changed. The Strait of Gibraltar is still the only inlet. Tectonic models project the strait will close again in approximately 5 to 10 million years. But before Earth rearranges its geography, there is the question of what happens when the threat comes not from below, but from the stars. Number 4. The Ordovician gamma ray burst, the day the sky burned. 450 million years ago, a hypernova detonated in a nearby arm of the Milky Way within 6,000 light years of Earth. It directed a focused beam of gamma radiation directly at our planet. The burst itself lasted approximately 10 seconds. Its effects cascaded for thousands of years. The gamma radiation shattered nitrogen and oxygen molecules in the upper atmosphere, destroying roughly 50% of the ozone layer instantly. The chemical reactions produced nitrogen dioxide, a brown, toxic gas that formed a thick haze blocking significant sunlight. That nitrogen dioxide combined with atmospheric water vapor to produce concentrated nitric acid, which fell as rain. Freshwater systems and surface ecosystems were poisoned from above. With half the ozone layer gone, ultraviolet radiation reached the surface at intensities capable of causing instant cellular mutations and destruction of soft tissue. The base of the marine food chain, surface-dwelling plankton, was directly exposed to lethal UV. The foundation of ocean ecosystems collapsed. Trilobites and other creatures with complex compound eyes were particularly vulnerable. The radiation intensity would have caused widespread blindness in shallow water species. Nitric acid smog eroded the gills of shallow water fish, turning every breath into a chemical burn. The technical term for molecular dissociation by ionizing radiation is radiolysis. The atmosphere was being torn apart at the molecular level. Ionization of the upper atmosphere would have produced permanent violent auroral displays even at equatorial latitudes, a glowing, toxic sky. Approximately 85% of all marine species were eliminated. The late Ordovician extinction ranks among the 5 worst in Earth's history, and then came the second blow. The brown nitrogen dioxide smog reflected enough sunlight to trigger a sudden ice age that froze the tropics. Researchers Adrian Malott and Brian Thomas published the foundational model in 2004, arguing a gamma-ray burst is a plausible trigger, consistent with the extinction pattern. Shallow water species were hit hardest, while deep water organisms survived. Water itself acted as a radiation shield. Hundreds of meters of ocean blocked the UV. Life was forced to restart evolutionary diversification from a few deep-sea survivors hidden in trenches and vents. Many paleontologists counter that the late Ordovician extinction can be explained entirely by glaciation and sea level change driven by Gondwanan ice sheets. No extraterrestrial cause is needed, they argue. And some researchers point out that the gamma-ray burst hypothesis is functionally untestable. We cannot prove a 450 million-year-old burst happened because its evidence is indistinguishable from other UV and ozone scenarios. Astronomers estimate Earth is struck by a gamma-ray burst of this magnitude roughly once every billion years, we are statistically within the window for another, and we would have zero warning. But if a flash from the cosmos sounds terrifying, consider what happens when the planet simply freezes solid for 85 million years. Number 5. Snowball Earth. The White Tomb. The cryogenian glaciations, the Sturtian and Marinoan events lasted from 720 to 635 million years ago. Approximately 85 million years of ice, 2 major freeze events, and a mechanism so relentless it has no natural break once started. The albedo trap is a positive feedback loop. As ice spreads, it reflects more sunlight, that cools the planet further, which spreads more ice, which reflects more sunlight. Once ice reached the equator, the average global temperature plummeted to roughly negative 50 degrees Celsius, negative 58 Fahrenheit. The planet's reflectivity exceeded that of the moon. This was not seasonal sea ice. The oceans were sealed beneath 1 to 2 kilometers of solid ice, a continental scale frozen lid over the entire water column. Light could not penetrate that thickness. Photosynthesis, the engine of nearly all surface life, effectively stopped on a global scale. With no liquid surface water to evaporate, it did not rain or snow for millions of years. Earth became a hyper-arid, frozen desert where moisture moved only through sublimation. The land surface was scoured rock and dry ice. Beneath the frozen lid, the ocean was cut off from the atmosphere. Dissolved oxygen plummeted as organisms consumed what remained. But beneath the ice, volcanoes continued erupting. They steadily pumped carbon dioxide into an atmosphere that could not shed it through weathering, because rain had stopped. Weathering is the natural thermostat that removes CO2 from the air. With that thermostat disconnected, CO2 accumulated to approximately 350 times modern levels. Eventually, the greenhouse effect overwhelmed the albedo trap. Melting began. The temperature whiplash was staggering. Global temperatures swung from negative 50 degrees Celsius to positive 50 degrees Celsius in a geological heartbeat, a 100-degree swing. The sudden melting produced acid rain so intense it dissolved exposed rock, washing dissolved carbonate into the sea and leaving distinctive cap carbonate layers in the geological record worldwide. Paul Hoffman and Daniel Schrag formalized the Snowball Earth hypothesis in 1998, citing glacial deposits at paleomagnetically confirmed equatorial latitudes and these cap carbonates as the key evidence. Life survived only in tiny pockets, near hydrothermal vents on the ocean floor, possibly in cryoconite holes, dust-filled pockets that absorb heat on glacier surfaces. Organisms survived by reducing their metabolisms to near zero, entering what amounts to biological suspended animation for millions of years. Beneath the ice, water became iron-rich and anoxic, a metallic-smelling, rust-colored dead zone. The ice was so heavy it pressed the Earth's crust down into the mantle by hundreds of feet, warping the planet's surface geometry. The slushball Earth model offers a counter theory. It argues ice never completely covered the equatorial oceans, that open water or thin ice persisted in the tropics, which better explains how photosynthetic life survived at all. Some researchers propose the freeze events were triggered by the breakup of the supercontinent Rodinia altering ocean circulation, combined with CO2 drawdown from weathering of fresh volcanic rock. Paradoxically, the extreme stress of Snowball Earth is the leading hypothesis for why cells first grouped into multicellular organisms. Cooperation was the only survival strategy. That evolutionary leap made everything that followed possible, including us. But the planet was not done splitting open. 135 million years later, it cracked along seams thousands of miles long. Number 6. The Karoo-Ferrar Eruptions. The Earth splits open. 183 million years ago, during the early Jurassic, massive eruptions broke out across what is now South Africa and Antarctica. These were not cone volcanoes. The Earth's crust split open along fissures spanning thousands of miles, oozing lava like an open wound. Geologists classify these as large igneous provinces. The critical mechanism was underground. Rising magma passed through enormous coal and shale deposits buried deep in the crust, thermally decomposing them. This coal cooking released trillions of tons of carbon dioxide and methane into the atmosphere. Sulfur dioxide and chlorine gas converted atmospheric moisture into sulfuric and hydrochloric acid. Acid rain fell on a planetary scale. The ocean absorbed so much CO2 that its pH dropped dramatically. The chemistry of seawater was fundamentally altered in a rapid acidification event. For carbonate-shelled organisms, clams, snails, corals, the results were grotesque. Their shells were being chemically dissolved while they were still alive, exposing soft bodies to the water. Surviving organisms could not extract enough calcium carbonate from acidified water to build shells, producing deformed, thinned, or absent skeletal structures. Researcher Stephen Hesselboe and colleagues published the key evidence in 2000, directly linking the Karoo-Ferrar large igneous province to the Toarcian extinction through carbon isotope excursions. The volcanic CO2 fingerprint is clear in the rock record. Marine animals that survived were 50 to 80% smaller than their pre-eruption ancestors. This pygmy effect reflects the metabolic stress and reduced resources that selected for miniaturization. The eruptions also release mercury at concentrations, causing widespread developmental defects and reproductive failure in marine reptiles. The heat from the eruptions warmed the oceans enough to trigger oxygen loss. The Toarcian oceanic anoxic event, recreating localized purple ocean conditions in the Tethys Sea. Sea levels rose by hundreds of feet purely from thermal expansion. In shallow lagoons, crustaceans were effectively cooked alive during peak temperature spikes. Ammonites, shelled cephalopods, experienced their spiral shells thinning and pitting until the soft squid-like body inside was exposed to predators and acidic water. Acid rain stripped nutrients from terrestrial soils, killing Jurassic forests and creating barren landscapes. 20% of all marine families were eliminated. The chemical changes to ocean water persisted for nearly 100,000 years after eruptions ceased. Some researchers argue the extinction was primarily driven by methane clathrate release that the volcanism triggered, making the eruptions the spark, but methane the actual killer. A minority view suggests the eruptions were part of an early phase of Gondwana's breakup, and the extinction pattern reflects geographic habitat fragmentation as much as chemical poisoning. Current ocean acidification from human-generated CO2 is proceeding at a rate comparable to the Toarcian event. Modern coral bleaching and shell thinning in pteropods are direct chemical parallels. But if acid dissolves shells from the outside, the next entry shows what happens when violence comes not from chemistry, but from human hands. Number 7. Nataruk, the first massacre 10,000 years ago. Approximately 10,000 years ago, at Nataruk near the western shore of Lake Turkana in northern Kenya, 27 people were killed. Their bodies were left exactly where they fell. No burial, no ritual, no care. This shifts the register entirely. We move from geological time to human violence, and the forensic evidence published by Marta Mirazon-Lar and colleagues in Nature in 2016 reads like a crime scene reconstruction. Skulls display massive, depressed fractures consistent with heavy clubs made from basalt. The damage patterns indicate deliberate, targeted killing blows. Obsidian stone tool fragments, microliths, were found lodged in knee joints and skulls of multiple victims. These tiny razor-sharp stone blades were embedded in wooden clubs to create shredding weapons designed to tear flesh. It was technologically sophisticated killing. Several skeletons had hands positioned in a crossed arrangement, suggesting they were bound with organic rope or cordage before being killed. Execution style. One woman was in the late stages of pregnancy. Her skeletal positioning indicates she was bound and stabbed. The fetus died with her. The absence of perifractures on forearms, the injuries caused by raising arms to block blows, suggests this was an ambush. There was no opportunity to fight back. The 27 dead included 6 children and 8 women. The attackers did not discriminate by age or sex. One individual's skull was struck with such force it was caved in from 2 different directions simultaneously. The bodies were left with their possessions, beads, tools. The motive was not robbery. The pattern, all ages, both sexes, no survivors, no plunder, is consistent with deliberate group extermination to remove competitors from a resource zone. The Nataruk Lagoon was fertile and resource-rich in an increasingly arid landscape as the Sahara began expanding. The bodies were quickly covered by lagoon silt, which preserved bone positioning and embedded weapon fragments, a natural forensic time capsule. This massacre occurred before writing. Without the chance preservation of these specific remains, this community's destruction would be completely unknown. Some researchers argue the evidence is ambiguous, that the bodies may represent a cemetery disturbed by flooding with apparent trauma caused by post-mortem taphonomic processes. The embedded projectile points challenge that interpretation significantly. A broader anthropological debate asks whether Nataruk reflects a universal human capacity for organized violence or a specific response to environmental stress. The answer matters, because Nataruk provides forensic proof that organized, premeditated mass killing predates agriculture, cities, states, and every institution we typically blame for conflict. The capacity for atrocity appears to be older than civilization itself, and while humans wielded clubs, Earth's chemistry was preparing another weapon entirely, one stored frozen on the ocean floor. Number 8, the Toarcian Turnover, the methane burp. The clathrate gun hypothesis describes a terrifying mechanism. Methane hydrate, often called methane ice, sits frozen in vast deposits on the seafloor. When ocean temperatures rise past a threshold, these deposits become unstable. The methane releases. Methane is 25 to 30 times more effective at trapping atmospheric heat than carbon dioxide over a 100-year time frame. During the Toarcian event, roughly 183 million years ago, trillions of tons of methane rose from the seafloor to the atmosphere in a matter of years. Not centuries. Years. A geologically instantaneous injection. The Karoo-Ferrar eruptions provided the initial warming. The methane provided the amplification. In some regions, sea surface temperatures spiked to 40 degrees Celsius, 104 degrees Fahrenheit, the temperature of a hot bath, lethal for most marine organisms. The metabolic death spiral was precise. At elevated temperatures, cold-blooded marine animals require more oxygen to sustain their metabolisms, but warmer water holds less dissolved oxygen. Demand rises as supply falls. Marine reptiles like ichthyosaurs, which relied on cool water to regulate their high metabolisms, died of thermal stress. They could not cool down and could not get enough oxygen. Species attempted to migrate poleward toward cooler water, but the thermal anomaly was so widespread there was no refuge, nowhere to go. The destabilization of seafloor sediments during methane release triggered massive submarine landslides, generating tsunamis that battered coastlines. Only opportunistic, low-oxygen tolerant species survived. Paleontologists call these disaster taxa, organisms that thrive in degraded conditions. A massive negative carbon isotope excursion in fossils from this period is the chemical signature of a methane release. The carbon in methane is isotopically light, depleted in carbon-13. Extreme ocean heat fueled hurricanes with wind speeds estimated to exceed 200 miles per hour. Storms of a magnitude with no modern comparison. A global explosion of fungi, visible as fungal spikes in the pollen record, consumed dying forests. In zones of high methane release, the air itself may have been intermittently flammable. The extreme thermal energy in the atmosphere dramatically increased lightning strike frequency, igniting global wildfires. Hesselboe and subsequent isotope work directly connect the negative carbon excursion to methane clathrate destabilization. Some geochemists counter that thermogenic methane, from volcanic cooking of organic sediments, could explain the isotope signal without invoking seafloor clathrates. The clathrate gun may never have fired, they argue. The most extreme models suggest that once a clathrate cascade begins, it is self-reinforcing. Warming releases methane, which causes more warming, which releases more methane. Some climate scientists fear this could repeat with modern Arctic permafrost destabilization. The estimated rate of carbon injection during the Toarcian event is directly comparable in magnitude to current human industrial emissions. That comparison is frequently cited in climate science literature. But the next disaster required no chemistry at all, just gravity, water, and an unstable slope. Number 9. The Storegga Slide Tsunami. The drowning of Doggerland. 8,200 years ago, an area of submarine sediment the size of Scotland, approximately 3,500 cubic kilometers, collapsed off the coast of Norway. The Storegga Slide. The cause was weight. Melting glaciers at the end of the last ice age deposited enormous volumes of sediment on the continental shelf. The load exceeded the slope's structural limits. The displacement of water created a wave that crossed the North Sea at roughly 500 miles per hour. It struck the Shetland Islands at 20 meters, 65 feet. It hit the British mainland at approximately 5 meters, 16 feet. The wave was powerful enough to move massive boulders miles inland. Doggerland was the target. A vast low-lying landscape connecting Britain to Denmark and the Netherlands. It was not a barren ice sheet. It was a habitable world of rivers, lakes, and forests. Among the most densely populated areas of Mesolithic Europe, prime hunting and fishing territory for nomadic bands, the topographic trap was lethal. Doggerland sat only a few feet above sea level with no significant high ground. When the wave arrived, there was nowhere to run and no elevation to climb. The tsunami did not simply hit and recede. It permanently inundated the lowest lying areas, converting habitable land into salt marsh and open sea. Before the tsunami, Doggerland had been slowly shrinking for centuries due to post-glacial sea level rise. The wave was the catastrophic final blow to an already diminishing world. Thousands of people are estimated to have died, a massive proportion of the total European population at the time. Stig Bondevik and colleagues published the detailed sediment analysis in 2005, confirming the Storegga slide as a single catastrophic submarine landslide. We know nothing about these people, their language, their stories, their names, their spiritual practices, their social structures. They left no written record. The physical evidence is underwater. North Sea trawlers routinely pull up mammoth bones, flint tools, and other artifacts from the submerged landscape. Geologists have identified distinct layers of marine sand and shell fragments, tsunamiites, deposited in the middle of inland peat bogs across Scotland and Norway. Some archaeologists argue Doggerland's population was already sparse by 8,200 years ago due to centuries of flooding and habitat loss. The tsunami may have struck an already diminished society. Others have linked the Storegga event to flood myth traditions in European cultures, speculating that oral memory persisted for thousands of years and influenced mythological narratives of drowned lands. The Norwegian continental shelf still contains unstable sediment deposits. Climate-driven glacial melt continues to load the crust. Britain became an island in large part because of what happened that day. And yet the most dramatic near miss in human history did not involve water. It involved fire, ash, and the near extinction of our species. Number 10. The Toba Bottleneck. Humanity's near extinction. 74,000 years ago, the Toba supervolcano on Sumatra erupted at VEY8, the highest possible volcanic explosivity rating, roughly 1,000 times more powerful than the 1980 eruption of Mount St. Helens. Approximately 2,800 cubic kilometers of ash and pyroclastic material was ejected, enough to cover all of South Asia in a layer 15 centimeters, 6 inches, thick. The eruption left a crater 100 kilometers long and 30 kilometers wide. It is now filled by Lake Toba, one of the largest volcanic lakes on Earth. Anything within approximately 80 kilometers was instantly incinerated by pyroclastic flows, clouds of gas at 1,000 degrees Celsius moving at 400 miles per hour. 6 billion tons of sulfur dioxide entered the stratosphere. Sulfur aerosols blocked sunlight so effectively that global temperatures dropped by an estimated 15 degrees Celsius, 27 degrees Fahrenheit. The planet was plunged into a volcanic winter lasting up to a decade. Tropical vegetation died rapidly. The equatorial green belt turned brown. The ash was composed of microscopic glass shards. Inhaling it would lacerate lung tissue from the inside. Rainfall for years carried the pH of battery acid, poisoning freshwater lakes, rivers, and streams. The Indian subcontinent was buried under the thickest deposits and remained essentially lifeless for decades. Stanley Ambrose proposed the Toba Catastrophe theory in 1998. Its most striking claim rests on genetics. Analysis of human mitochondrial DNA reveals a dramatic reduction in genetic diversity at this time. The total breeding population of Homo sapiens dropped to an estimated 3,000 to 10,000 individuals. At our lowest point, humans were more endangered than modern mountain gorillas. One bad season, away from total extinction. Every major food source for Paleolithic hunter-gatherers collapsed. Fruit, tubers, large game animals all failed cascadingly as ecosystems shut down. For roughly a decade, the sun appeared as a dim red smudge through a permanent gray haze. For a species whose survival depended on solar cycles, the psychological toll would have been immense. Some geneticists hypothesize that Toba's devastation triggered or accelerated the final major migration of modern humans out of Africa. Arctic and Antarctic ice cores contain a distinct layer of volcanic ash and sulfuric acid at precisely this date. A global chemical timestamp. Recent archaeological work complicates the picture. Michael Petraglia and colleagues published findings in 2007 showing stone tool traditions in India continuing uninterrupted through the Toba ash layer. Human populations may have been more resilient than the bottleneck hypothesis implies. Some researchers argue the genetic squeeze predates Toba entirely, caused instead by a preceding glaciation event. The near extinction may never have happened as a single event, but if the evolutionary spark hypothesis holds, if only the most cognitively flexible, socially cooperative groups survived, then our intelligence may be a direct product of catastrophic stress. Who we are may have been forged in volcanic winter, the end Permian return of the Purple Ocean. 252 million years ago, the worst mass extinction in Earth's history eliminated approximately 96% of all marine species and 70% of terrestrial vertebrate species, the Great Dying. The trigger was the Siberian Traps, a flood basalt province that erupted over roughly 2 million years, producing an estimated 3 million cubic kilometers of lava. The volcanic CO2 and resulting ocean warming recreated the same sulfidic oxygen-depleted conditions described in the first entry of this documentary. Eusenia returned. Biomarker evidence, specifically Eiserinia retaining, a pigment unique to green sulfur bacteria, found in Permian-Triassic boundary sediments, proves that toxic sulfur-rich water reached the sunlit surface layer. Photic zone Euxinia confirmed in the rock record. Hydrogen sulfide gas venting from the Euxinic Ocean poisoned terrestrial ecosystems. The same gas that characterized the billion-year Purple Ocean now killed land animals. H2S destroyed ozone, allowing lethal UV radiation to reach the surface. Mutant spore assemblages in the fossil record show UV damage to plant DNA. Reef ecosystems built over tens of millions of years collapsed within tens of thousands of years. Forests were replaced by fungal blooms. Equatorial sea surface temperatures may have reached 40 degrees Celsius, with land temperatures exceeding 50 degrees Celsius in continental interiors. Dissolved oxygen in most of the ocean dropped to near zero. It took approximately 10 million years for biodiversity to recover, the longest recovery of any mass extinction. There's a worldwide gap in coal deposits spanning millions of years after the event. Forests were so thoroughly destroyed that insufficient plant material accumulated to form coal. Tiny eel-like creatures called conodonts were among the few vertebrates to survive. Their small size and low oxygen requirements gave them an edge. The identification of specific bacterial pigment molecules in 252 million-year-old rocks is one of the triumphs of molecular paleontology, chemical fossils where body fossils are absent. Paul Wignall, Michael Benton, Douglas Irwin, and others have established the Siberian Traps to CO2, to warming to ocean anoxia causal chain. Some researchers emphasize the extinction was pulsed, multiple kill mechanisms operating at different times. A minority view proposed by Luan Becker and colleagues in 2001 suggested a bolide impact coincided with the Siberian Traps, though the evidence remains largely rejected. The end Permian proves the Proterozoic Purple Ocean was not a primitive phase. It is a thermodynamic attractor, and today's expanding ocean dead zones follow the same chemical trajectory, which leads to an uncomfortable question: how many of these patterns are active right now? The deep time pattern, recurring extinction mechanisms. Across all 10 events in this documentary, the same handful of kill mechanisms appear repeatedly. Ocean anoxia, atmospheric poisoning, UV exposure, thermal stress, acid rain. The specific triggers vary: volcanic, cosmic, biological, tectonic. The downstream chemistry is the same. In at least 4 of these events, the Purple Ocean, the Karoo-Ferrar Eruptions, the Toarcian methane burp, and the end Permian, the causal chain follows an identical path. CO2 rises, temperatures rise, ocean oxygen drops, Euxinia develops. Earth's ozone layer has been breached in at least 3 independent scenarios: hydrogen sulfide attack, gamma radiation, and volcanic halogen release. Methane clathrate destabilization appears as a feedback amplifier in the Toarcian, the end Permian, and potentially any future warming event. It is the universal accelerant. Reef collapse appears in the Devonian, the end Permian, and the Karoo-Ferrar event. Reef ecosystems are consistently the first complex systems to fail. The deep ocean served as the primary survival zone in the Ordovician, Snowball Earth, and the end Permian. Water is the most reliable radiation shield and thermal buffer on the planet. Multiple events show a double tap, 2-phase killing. The Ordovician delivered burn, then freeze. The Devonian delivered nutrient flood, then ice age. The end Permian delivered heat, then anoxia. Single-cause explanations almost always understate the severity. Recovery timescales are sobering. 20 million years for reefs after the Devonian, 10 million years after the end Permian, 5 million years after the Toarcian. These are not quick rebounds. Euxinia, ozone loss, and thermal runaway are not random. They are thermodynamic attractors that Earth's climate system falls into when pushed past thresholds. Different triggers produce the same downstream effects because they all operate through the same atmospheric and oceanic chemistry. Convergent catastrophe. The Devonian plant invasion shows that life itself can trigger mass extinction. The biosphere is not always stabilizing, it can be destabilizing. The Messinian crisis demonstrates that continental configuration controls ocean circulation, which controls climate. Plate tectonics sets the stage. Some paleontologists caution against pattern matching across such different events, arguing each extinction has unique triggers and overgeneralization obscures more than it reveals. Variants of the Gaia hypothesis suggest Earth has self-regulating mechanisms that should prevent catastrophic failure. The recurring extinctions challenge that view, or at minimum, suggest the regulation operates at timescales irrelevant to any individual species. The same chemical vulnerabilities that existed 2 billion years ago exist today. And the same triggers remain active. Modern echoes, the same chemistry, different century. The global ocean has lost approximately 2% of its dissolved oxygen since the 1960s. Oceanic dead zones have quadrupled in area since 1950. The directional trend matches pre-Eocenic conditions. Every summer, the Gulf of Mexico's hypoxic zone, 15 to 22,000 square kilometers, recreates the identical eutrophication mechanism that caused the Devonian marine extinction. The Great Barrier Reef has experienced mass bleaching events in 2016, 2017, 2020, 2022, 2024, and 2025. Reef collapse is the same early warning signal that preceded the Devonian, Permian, and Toarcian extinctions. Current ocean pH is dropping at approximately 0.1 units per century. It is measurably thinning the shells of pteropods and reducing coral calcification rates. An estimated 1,500 gigatons of carbon is stored in Arctic permafrost, with additional methane clathrates on Arctic continental shelves, the same reservoir type that produced the Toarcian methane burp. The Atlantic meridional overturning circulation has slowed measurably, echoing the stagnant oceans of the Proterozoic. Earth system scientists Will Steffen and Johan Rockström have defined 9 planetary boundaries. Ocean acidification, biodiversity loss, nitrogen and phosphorus loading, and climate change are all boundaries currently being approached or exceeded, everyone with a deep time precedence. Current species extinction rates are estimated at 100 to 1,000 times the background rate. The Big Five mass extinctions all began with elevated extinction rates before reaching crisis levels. Some geologists argue comparing modern change to deep time events is misleading. The end Permian volcanism lasted millions of years. Human emissions have operated for roughly 200. The timescale difference matters for biological adaptation. Others, sometimes labeled collapsologists, argue we are already past critical tipping points. Mainstream science considers those positions premature, but acknowledges the underlying mechanisms are real. Unlike any previous extinction trigger, the current situation is being monitored in real time by thousands of instruments. We have information no prior biosphere ever had. What deep time teaches: resilience, fragility, and luck. Across all events, survivors share common traits: small body size, low metabolic oxygen demand, habitat in deep water or underground, dietary flexibility, victims share the inverse, large body size, high metabolic rates, surface habitation, dietary specialization, calcium carbonate dependence. The Devonian placoderms, Toarcian ichthyosaurs, and Permian reef builders were all large, energy-intensive organisms. Bigness is an advantage in stable times and a death sentence during disruption. In the Ordovician, Snowball Earth, and the end Permian, deep ocean organisms survived at far higher rates. Water is the most reliable buffer on the planet. The Snowball Earth bottleneck may have driven multicellularity. The Toba Bottleneck may have selected for cognitive flexibility and social cooperation. Both suggest that catastrophic stress can drive evolutionary innovation, but only for the survivors. Geographic luck determined who lived and who died. The Storegga tsunami killed everyone on Doggerland, but left populations 100 miles east unharmed. Survival was often about location, not fitness. After every extinction, the first organisms to rebound are generalists and opportunists. Specialists take millions of years to re-evolve. The 20 million year reef gap after the Devonian and the 10 million year recovery after the end Permian demonstrate that some structures, once destroyed, do not return on any human-relevant timescale. Every event before approximately 5,000 years ago is known only through physical evidence. The Nataruk massacre, the Doggerland drowning, the Toba winter, remembered only because geology preserved what memory could not. We have better data on a 252 million year old ocean chemistry event than on a 10,000 year old human massacre. Physical science preserves what culture erases. The Ordovician gamma ray burst struck because a star happened to die while pointing at Earth. No adaptation, no strategy, no innovation can protect against that category of threat. Resilient science, developed by researchers like C.S. Halling and Brian Walker, treats deep time extinctions as case studies. The key variable is how quickly a system can reorganize after disruption, not whether disruption can be prevented. But survivorship bias is real. We study the survivors and construct narratives of adaptation. The overwhelming majority simply died. Deep time reveals that survival is a combination of adaptation, cooperation, and blind luck. No single factor is sufficient. The absence of any one can be fatal. This documentary covered approximately 1.8 billion years of Earth history across 10 events. Everyone operated through known physical and chemical laws. The albedo trap, adiabatic heating, thermal expansion, and greenhouse forcing are all expressions of basic thermodynamics. The same equations govern Snowball Earth and modern climate models. Ocean acidification, euxinia, ozone destruction, and acid rain are acid-base and redox chemistry. The periodic table has not changed in 4.5 billion years. Eutrophication, biological weathering, methane production, and photosynthesis disruption show that life is both the beneficiary and the agent of planetary chemistry. The Messinian crisis, the Storegga slide, and the Karoo-Ferrar eruptions demonstrate that Earth's internal heat engine reshapes surface conditions on timescales from hours to millions of years. Every surviving lineage, from cryogenian extremophiles to Toba humans, solved a problem imposed by fundamental physics using biological or behavioral innovation. Positive feedback loops, the albedo trap, the clathrate gun, the eutrophication cascade, are the most dangerous pattern in Earth's history. They turn gradual change into sudden catastrophe. For the first time in 4.5 billion years, one species can measure these processes in real time. Every horror in this documentary began with a small change. A few degrees of temperature, a few percent of oxygen, a tectonic shift of a few centimeters per year, and then it crossed a threshold.